Somebody be brave and give me T1 and T2. So it's a question or answer? Go ahead. Yes. T1 and T2. Go ahead.
-2 and 3.
Good. So you can write here. These are given. That's what we should start off here. Okay, T3 is where life starts to get a slight bit more complicated. Can I get someone to be brave to give me the equation for T3? And then we'll actually start with the numbers here. Ben, go ahead.
2 times -2 plus 3 times 2 is plus 1.
Yeah, I'm going to do it even more basic than that. Okay, but you're right. Okay, I'm just going to write that just so that we can all follow what happened. Okay, 9 plus 1 is 10, 10 minus 4 is 6. Is that right? Can you confirm that for me? No? Yes, confirm?
I got 14.
Check again. I'm going to give us a negative.
Okay.
Thanks. Okay, can someone other than Ben be brave and give me T4, please? Go ahead.
Okay, so it'd be like T4,
Yeah.
and then 2 times 3
Okay.
plus 3 times 6 plus 1.
I'm going to write that in formal form. 18 and 6 is 24, that's 25. You good? Does that sort of make sense before we make life difficult? Okay, the more difficult thing now is making the equations. Like, it's wonderful that we can write them out. Okay, but let's make the equations. My suggestion, could you do this, guys, please? My suggestion is to continue the pattern. To T0 treat like y in. Okay. So what we're going to do is I'm going to give you a few equations. We're going to try and make the general term. Okay, the general term, what it does, as we said, it's going to be used to find any term in the sequence. So what will happen on your quiz or your test will be, I'll say the number of seats. So always a word problem I do, and I'll actually maybe do it again today. Okay, so maybe I won't say it again. So example 1 is going to say T0, that should be like 2 and then T subscript 0. Okay, T0. Okay. So example 1 is going to say find the general term of the sequence. That's right. Uh, 4, 6, 8, 10. Now, let's say the name is Ben, and I hate to embarrass Ben, but I'm going to. And he can look at that and say, well, yeah, clearly that's going to be 2x plus 2, and he doesn't even need to think about it. That's fine for this. This will be like a 1 marker on formula for right now. For those people that can't see the pattern to this, I'm going to show you the way to do it to make your life easier. The way I am going to recommend to do it, and again, this is optional. Don't need to listen to me. I'm just going to write T1 equals 4, T2 equals 6, T3 equals 8. What I'm going to do is, as I was saying before, is I was going to go upwards. You guys are done at the same time? That's unbelievable.
We're doing different tests.
Okay, this is unbelievable still. Okay, so, where's my close? if I follow the pattern backwards, what's T0 going to equal going backwards there? 2, okay? So what's going to happen is here, we're going up by 2 each time, right? If you're increasing by 2 each time, how do I write that as an equation? You're going up by 2 each time. No. Sorry? Sorry? No, Tn will not equal 2. No. Okay. Because when you're, because think the way you're thinking, the reason it goes to 2n, guys. Just think for 1 sec. Can I talk, please? One way to think of it is like a first difference, okay? If you're going up by 2 each time, it'll be a first difference of 2. The other way to think about it, repeated. When you're adding something again and again and again, repeated addition is multiplication, okay? Now again, if you're not sure about your equation, I know that T3 is equal to 8, so you can check. So that's a good check for yourself to do that. Okay. Question on where that first equation came to before I move on to things that are worse. You guys are way too nice. We're all good? Yes, linear. We're good with linear. We have to do 1,000 of these tonight, so I hope we're good. Example 2. I should have 2 more examples on myself. Now find the general term. Okay, so the way we're going to do this here, we're going to start with the pattern. What's my pattern that I'm actually doing here each time? What's the pattern going to be? Right? Multiply by 2 each time, right? Okay, great. Excellent, tremendous, even. Okay. How would you write multiplying by 2 again and again and again? How would I write that? No, not 2 to the 2. How would you write if you multiply? Yeah, go ahead. It wasn't? You're just stretching? Stretching is okay. If you multiply 2 5 times, how do you write that? 2 to the 5, good. So I'm gonna, if you multiply 2 n times, how do you write that? 2 to the n, good. So this is going to be represented by 2 to the n. But I do the same thing I did before, and then put a 2 0 and hit 2 zeros here as your starting point. Okay. So if this is 3 and that's 6, what's T0 going to be in this case? Okay, what's the pattern that we used here? Nope. How'd you get 1.5, Georgie? Right? Because remember the pattern is going to be, we said times 2 and times 2, right? So my equation is going to be Tn equals 1.5 times 2 to the n. And again, if you don't believe me, and you don't, okay, try an equation. I know that T4 should be 24. So T to the 4 should be 1.5 times 2 to the 4. 2 to the 4 should be 2, 4, 8, 16. 1.5 times 16 is 24. That's just my check. So the point is, you need that starting value in order to get that. Am I going to give you a cursive? I'll give you one word, probably one. Here we go. One word problem. Example 3. Thanks, I love this question. Example 3 says, Logan is sitting at a hockey game. and realizes that the seats go in a pattern 90, 93, 96, 99, etc. If Andrew is sitting in the 35th row, how many seats are in his row? Okay, this will be a lovely test question for you. Okay. So it says here, Logan is sitting in. And realize that the seats go in a pattern 90, 93, 96, 99. Right? If Andrew is sitting in the 35th row, how many seats are in his row? Now this is where, unfortunately, this is unfortunately where the term football method, as try to make a fool of myself up here, comes from. Because I used to have a football player in my class that when he did this question, he counted on his fingers. So if anyone ever counts on their fingers up to 35, I'm going to say Logan is at a spaceball game. Spaceball, get that? Where they're in space. And the first row has 90, and there's 10 billion rows in the stadium. Okay, so it's impossible to use your fingers to get that high. Okay, so don't do that, because there was a student who did that, like they did like 342 rows or something, right? And they, you know, right? So please don't do that. Okay, the hint for this one is we're going to follow what we just did. Let's start with a general term. What's the pattern between 90, 93, 96, and 99? What's the pattern going to be? Add 3 each time. Okay? So my pattern is going to be add 3. So what I'm going to do is I'm just going to write something like this. And I'm going to go backwards. I heard somebody say it. Good, go backwards, find out what T0 is. What's T0 going to be, Madison?
Would it be 87?
It would be 87. Okay. So how, if you're adding 3 each time, what's my equation going to be for this? If you're adding 3, or your first difference, haha, is equal to 3. Okay. Not 3 at the end, not 3.
Plus 3.
Okay. So what this is going to be, guys, do this please. So this is going to turn into T to the n equals 3n plus 87. Where n is going to be your rows, Tn is going to be your seats. Now, for those that have been here the whole class, is everyone comfortable with 3n plus 87, where that came from? Was someone comfortable? Look a little bit.
Let's add 3.
Why do you have to include the 0?
Well, because otherwise,
Like your beginning.
yeah, it is like your beginning. That's what you're going to need, right? Because the thing about like a y-intercept, like think about it like that. It's just like your starting point. Okay. All right. So the question is, Andrew, I'm coming on you. If I want to find out how many seats I find in your row, how do I figure that out? I heard Logan say it. Yeah, we're going to find T35. Okay. Because that's going to be the 35th row. Okay. Ben, with the power of your calculator, can you tell me what the answer is here, please? T35 is going to equal 3, times 35 plus 87.
92.
Okay. I knew that there was math at a hockey game. Not that we're at a hockey game. Therefore, there are 192 seats in Andrew's row. Homework. Page 439, number 3 to 7. Page 443, number 3. And page 447, number 8. Okay. Get back in the habit of using this stuff. These, especially for today's lesson, the recursive stuff is tricky. It's not obvious. Okay, that we did there. Okay, so those are tricky. Hopefully, you guys will feel good about this unit. As I said, it used to be chapter 1 for me in the old book, and it was the easiest. And trig was at the end, right? So, if you're just joining us, if you're writing a test, what I decided to do is I put trig after Christmas. Okay. All right. Hope I recorded that. Good.